Okay, I'm now going to demonstrate my final integration project. So what we can see here is we've got the ultrasonic sensor connected. So it's got its ground power coming from 3.3. Then it's got an echo cable and a trigger cable. So the trigger cable will trigger pulses to be sent. They will come, bounce off, and the distance will be measured. That will be sent through the input cable, the echo cable, which will then be read. My program will then read it and send it to the controller here, which will then be passed to the stepper motor, which will take that many steps. Upon making too many quick movements, so moving closer to the ultrasonic sensor, it will be calculating the velocity of those movements. And if you make too many quick movements, the LED, it will start to flash through various levels. So up to 30% of the mistakes, it'll be at level 1. At between 30 and 60% of mistakes, it'll be at level 2. And at 60+%, it'll be at level 3 before it resets once you've hit the maximum number of mistakes. Once you hit the maximum number of mistakes, this stepper motor does a revolution, and then it begins measuring again. I will now run it and show you how it works. Okay, I'll now demonstrate the circuits function. So the user first inputs the number of failures that will be accepted, and then it will start measuring the distance from the cardboard piece. As you can see, the motor is moving along with the movements of the cardboard. The LED flashes to indicate the warning status, and when you pass the number of allowable errors, it will do a full revolution before measuring once again. Now, quickly looking at the code, we can see the user can enter their number of failures, and then it'll initially start calculating. So we can see the printout, and it's showing all of the distances and the speed between inputs. So there I've moved it too quick, and so it's paused. The counter is increased, and now this is when it takes the full revolution and comes back. And so that is calculated with an algorithm I've made.